All right. Let me officially welcome you guys to my YouTube channel. This is, basically for my IPStat students. So now I've officially got a mic. So as I go through these problems from our mock exam, I'll be able to add commentary and kind of share my thought process as I'm doing the problem. So we're looking at question 33 here. It says, for two events, A and B, the probability of A, which by that they mean the overall probability of A, is 40%. The overall probability of B is 30%, and the probability of A or B is 58%. Which of the following statements must be true? So for a lot of probability questions, you are going to want to use some sort of graphic organizer. So the ones that we learned in class were the two-way table, Venn diagram, or tree diagram. So as soon as I saw this problem, right away I was thinking of a two-way table. So I started to draw a two-way table where I have in the first row A occurs, in the second row A does not occur, and we'll have totals on the bottom. B occurs, B does not occur, and then again totals. Now since all the values are in proportions, I know that the grand total is going to be 1, aka 100%. We know the overall probability of A is 40%, so we can go ahead and write that in the total. And we would then also infer that the probability that A does not occur is 60%, right? 40 plus 60 is 100%. The overall or total probability that B occurs is 30%, so put that in the bottom of the first column. The chance that it does not occur would therefore have to be 70%. Okay? And so we've got all the marginal probabilities filled out, but what's missing is the probabilities on the inside. And for that, we're going to have to use one of the formulas. You'll find it on the formula sheet. Okay, and that would be that the probability of A or B equals the overall probability of A plus the overall probability of B minus the probability of both. Okay, and so there's kind of 4 terms in that equation, and we know 3 of the values, so let's go ahead and substitute those in. Right, so the probability of A or B we know is 58%, the probability of A is 40, the probability of B is 30. The only probability we don't know is the joint probability, A and B. And so I just wrote X there. We'd use a little bit of algebra, right? 40 plus 30 is 70, isolate X. And what you end up with is X equals 12. Okay, great. So the probability of A and B both occurring is 12%, and that would be represented by the upper left cell in the two-way table. Okay, so 12% there. And now we're just going to fill out the other 3 boxes. It's kind of like solving a Sudoku. We're just using mental math here. The upper right box is going to be 28% because that has to add up to 40. The lower left box is going to be 18%, so that column adds up to 30. And then the bottom right box is going to be 42%. The row adds up to 60. The column has to add up to 70. Okay. So now that we've got this graphic organizer, this two-way table, let's start looking at the answer choices. Now pretty much every answer choice is mentioning something about either independence or mutually exclusive events. Okay? So let's remind ourselves of those definitions. Okay? So mutually exclusive means that the 2 events cannot happen together. In other words, the probability of A and B both occurring would be 0. But we know from the work up here in the top right corner that the probability of A and B is actually 12%. So we know that these can occur at the same time, which means they are not mutually exclusive. Okay? So now we can start eliminating some answer choices. Okay, so B can no longer be right and C can no longer be right. Okay. Now the other term in this problem is about independence. Okay, so independence means that the conditional probabilities are going to be equal to the overall probabilities. So I think the formula is like the probability of, B given A is the same as the overall probability of B. All right. So let's do some quick calculations to see whether the conditional probability would be equal to the overall probability. Okay. So if we look at, let's see here, the bottom row, right, we can say that the overall probability of B is 30%, right? 30 divided by 0.30 divided by 1. Okay. So that's the overall probability. Okay. Now let's turn our attention to the first row in the table. Okay. In that row, we know that A has occurred. So there's our condition. Okay. So we can say that the probability of B given A is going to be the ratio 12% out of the total 40%. And if you throw that in a calculator, 12 divided by 40 is also 30%. Okay? So with some quick calculations, we have now found out that the conditional probability is the exact same as the overall probability. They're equal, therefore these two events are independent. Okay? So now we know what the right answer is. These events are independent, but they're not mutually exclusive. And that's what choice A says.